Okay, you're welcome to today's class. Today we want to look at full adder. The last class we did half adder, right? And we saw how half adder is used to add a binary bit. What that last class didn't show us was the effect of the carry, meaning if a nation is so powerful that they have to extend their influence, what is the effect of that their influence into another sovereign nation? The half adder didn't show us, so we are going to see it in the full adder. Now, what the half adder did was just to add 1 plus 1 equals to what? 2, which is 0, and you carry 1. Well, what if I want to, what if I want to add something like 0, 1, 1, 1? This is 7, right? And then plus 0, 0, 0, 1. Now, how is the computer going to do this arithmetic? Now, this plus this is 2, but you cannot write 2, so you write 0, you carry 1. Now, that one you carry is here. Now, this is another sovereign nation, a different reality. So 1 plus 0 is what? 1. But because of that carry you brought from the previous reality, it will become 2. So you write 0 again, you carry 1. So you see, it's shifting. Now, I told you in positional number system, I did something like this. 2 raised power 0, 2 raised power 1, 2 raised power 2, 2 raised power 3, right? This is 1, this is 2, this is 4, and then this is 8. So meaning the first realm can only take one state. So the second realm can take 2 states. The third realm can take 4 states. The fourth realm can take what? 8 states. So once it is more than what this state can occupy, you have to move it to this other side. And that is the effect of that carry. So when 1 plus 1 equals to 2, it means that this first state can no longer carry that 2. So you have to put 0 as a placeholder, and then you have to shift. So you continue like that, then this place will come 1 again, and then it will give you 0, then this one will give you 1. So this will give you what? 8. Right? Now, how is computer going to do this? Because if you use half adder for this, half adder will take care of this part, half adder will take care of this part, half adder will take care of this part, half adder will take care of this part. But what about the carry that is coming from the previous state? Half adder cannot handle it. So you need full adder to be able to achieve that. So let's go ahead. Now, since I'm having 2 inputs, right, in that current state, plus the carry input that is coming from the previous state. So that means I will need 3 inputs. So having 3 inputs, that is 2 raised power 3, that will give me what? 8 pattern existing in the overall realm. Okay, so let's design it. So we are having something like this. Right? So we are having, this is A, this is B, and then this is carry. So I'll call it carry in. So C in equals to what? Carry in, right? C out will be what? Carry out. So this place will give me sum as my output, and then let's call it C out, which is what? Carry out. So since I'm having 3 inputs, A, B, and carry in, so 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right? So these are my 4 inputs. 0, 1, 0, 1, 0, 1, 0, 1. 0, 0, 1, 1, 0, 0, 1, 1. 0, 0, 0, 0, 1, 1, 1, 1. Now, if you look at this, place, this is already similar to what? What will it give me? So 0, 0, 0, that is 0 plus 0 plus 0 will give me what? 0. Output will be what? 0. 0 plus 0 plus 1 will give me sum as 1. Output will be what? 0. 0 plus 1 plus 0 will give me what? 1, 0. 0 plus 1 plus 1, that is 2. So sum will be what? 0. Output will be 1. You can see this is the output of my what? Half adder. Now I'm bringing in this. So this is like the carry in. This should have been here anyway. So 1 plus 0 plus 0 will give me what? 1. And then output is what? 0. 1 plus 0 plus 1 will give me 2. So sum is 0, output is 1. 1 plus 1 plus 0 will give me 2. So output is 1. 1 plus 1 plus 1, that is 3. So that will be 1 here and 1 here, which is the same thing with what I did. When I say 2 raised power 0 will give me 1. 2 raised power 1 will give me 2. 2 raised power 3 will give me 2 raised power 2 will give me 4. So I'm already saying that 1 plus 1 plus 1 equals to 3. The first dimension can only take 2. The second dimension can take, the first dimension can only take 1. The second dimension can take 2. So 2 plus 2 will give me 3. So I'm going to split that my output into these two realms. That's why I'm having 1 here and 1 in this place. But the 1 in this place is representing this frequency. It's not the same thing as the 1 that is in this place. That is what this is telling you. Now, if this is my output, let's look at this again. What can we derive from this table? If you look at this sum, what do you notice? You will count how many 1. So we have 1 here, you have 1. You have 1 here, you have 1. If you have 2 here, you have 0. You have 1 here, you have 1. If you have 2 here, you have 0. So what you can derive from this table for the sum is that if you have odd, so sum, right, is talking about odd and even, right? Sum is looking at odd and even. If it is odd, sum is what? 1. If it is even, if the number of input is even, sum is what? 0. That is what you can derive here. So you can see 0, 0, 0 will give you 0. 0, 0, 1. How many 1 is there? 1. That is odd. It will give you 1. How many 1 is here? It will give you 1. How many 1 is here? Even 1. That will give you 0. How many 1 is here? Odd 1. That will give you 1. So that is what you are deriving from this place. So sum is still exclusive OR. Sum equals to A exclusive OR B exclusive OR Cin. That is what you are deriving from this. Now, if you look at the count, if you look at this count, you will notice something is happening here. Sum is looking at odd and even for the input, while count is looking at least 2 input being 1. If you look at this place, only 1 input is 0. No input here, 0. 1 input, 0. 2 input, 1. 1 input, 0. 2 input, 1. 2 input, 1. More than 2 input, 1. So at least 2 input must be equal to what? 1. And you will get the output to be what? 1. That is another thing you can derive by just looking at this truth table. So if that is the case, for this Cout equals to at least 2 input, meaning AB plus AC plus BC, right? This is what we can derive from this truth table, this equation and this equation. So what it therefore means is that if I am having 3 switches, if 2 of the switches can be on, my output will be on for sum. So I'm having for Cout, I mean. So I'm having sum and I'm having Cout. So let's do a calculation to see if this one is correct. If we have, so since we say A exclusive or B exclusive or C equals to what? Sum. Now let's do it. A exclusive or. So 0 plus 0 plus 0 equals to what? 0, 0. That is sum and carry, right? Now you hold this carry and you take this sum, add it to this one, it becomes 0 plus 0. It will give you what? 0, 0. So this is your final sum. This is or it. So it will give you, carry will be what? 0, and sum will be what? 0. That is correct, right? Now, if we come to this one, if we say A, B, so 0 plus 0 will give you what? 0, 0. And sum, this is sum, and then this is carry, right? So we are going to take the sum part because we are looking at the exclusive or. So we'll take the sum part, we'll hold on to this carry. So this sum plus this one, which is 1, that will give you 0, 1. So this is sum again because we are looking at the exclusive or part, but this is the carry part. So if you add this together, so that will give you 0, 1. So the final sum is 1 and the carry is 0, right? Final sum is 1, carry is 0. So that works. Now let's test it again for this guy. If A is 0, 0 plus B, which is 1, equals to what? 1. Carry is 0, right? So this is carry and this is sum. So hold this carry, bring this sum, which is what? 1. 1 plus 1, which is this C, will give you what? 2. And that is what? Carry is 0 and sum is 0, right? So this one was partial sum. This is final sum. So if the final sum is 0, then you look at the first carry and the second carry. So you OR it. So this will give you what? 1, 0. So final carry is 1. Sum is what? 0. Sum is 0. Final carry is 1. Let's test it for this guy. Let's test it for the last one. You take this A and B. So 1 plus 1 will give you what? 2, which is 1, 0. You know, we are looking at the exclusive OR part. So sum is this part, which is this one. So this is the carry, right? So keep this carry, bring this sum, which is 0. Now, do exclusive OR with this one again. 0 plus 1 will give you what? 1. So carry is 0, right? So this is the final sum, meaning you took this sum and you gave it as an input. So this is the final sum, and then you have another carry. So this carry and this carry, or it's, so that will give you 1, 1, which is what? 1, 1. It therefore means that a full adder, based on what we've done, it means that a full adder, right, equals to 2 half adder plus OR gate. That is what it means. That a full adder equals to 2 half adder plus what? OR gate. But what you can deduce from this truth table is that for the case of sum, we are looking at the difference. We are looking at even and odd. If inside these 3 input, we are having odd as the input, that is just one switch is on, it means that the output, the sum will be what? 1. If we have 2 input on, it means the sum will be 0. If we have 3 input on, if we have even, it means the sum will be 0. If we have odd, it means the sum will be what? 1. That is what this is telling us. And then this C out is telling us at least 2 of the input must be 1. That is what we can derive here. If I have to draw the Carnot map and then the circuit for you using this class will be too long. So I'm going to pause here, and then in the next class, I'm going to show you the Carnot map for this full adder, and then we'll also draw the circuit diagram from the function we will derive from the Carnot map for this. So don't forget to like and don't forget to subscribe if you have not done so. So till we see in the next class. Bye-bye.